All right. Hey guys, welcome to week 5 of Techquitable Features. This week, we'll be covering the topics of stacks and queues. And it will be led by our two wonderful mentors, Viveka and Deandra. All right. And then Deandra, do you want to take it away?
Yeah, of course. So hi everyone, I'm Deandra, and the topics we'll be covering today are going to be stacks and queues. So I'll start off with stacks, and then later on, I'm going to hand it over to Viveka, and she'll teach you all about queues. So stacks are a pretty simple data structure. If you think back a few weeks ago to the lesson where we went over arrays, it's an extension of that concept. There are a few different particulars that make it more suited for certain problems, and we'll get into that later on. So it's using a lot of different algorithms, traversing binary trees. There's a problem called the stock span problem that deals with prices in the stock market. And that's actually a very common one, so common that I actually had it for the interview for my full-time job that I have now, was one of the questions I was asked. It's also useful for checking if things are balanced, and you'll see some of these patterns later on in the example problem that we'll do. So the full definition. So a stack is a linear data structure, represents a collection of items, and the key here is the ordering. So the term you'll hear a lot with stacks is LIFO, or last in, first out. And what that's referring to is how things are added to and taken out of the collection. So the canonical example of this is if you have a stack of plates at a cafeteria. You walk into the cafeteria, if you want to grab a tray or a plate, you take the one from the top. You don't go all the way to the bottom and try to take one off. So that's how stacks work. And that tray that you're taking off would have been the last one that the workers had put on top. So the last thing that ends up on top is the first thing that you'll take out when you're going in. Another example of this in more of a sort of digital design is the back button on your browser. So if you press back, it'll take you to the last thing you just saw. So that would be the first thing that comes off, that's returned to you. It won't take you to the first page that you ever went on when you signed on to your internet browser. It's going to take you to the last thing you're on. So that concept of the last thing that was added to the collection is the first thing you'll return. That's the key thing that differentiates stacks from any other linear data structure. So the main operations we'll discuss for stacks are going to be push. So push is the term that we use for adding something to a stack. So adding that tray onto, the clean tray on top of the stack of the cafeteria trays. That's pushing. And because we don't care anything about the trays that are underneath, all we're doing is adding something on top. It's O of 1. It's constant time. Same thing with popping, which is the term we use for removing an item from the stack. We don't care about the things that are below. All you're doing is taking that tray off the top. That's constant time. And of course, here we have noted the two sort of edge cases. If you have a preset amount of memory, the stack could be full and maybe you can't push something. Or maybe if the stack is empty, you can't pop something. So those are also things to keep in mind with data structures. You always want to think about overflows and underflows. And then here's some other operations that you'll want to use. So peeking is very similar to popping, but it's just looking at the top thing. You're not going to remove it. So let's say you have like a deck of cards, and if you wanted to find out which card is coming next, but you don't want to take it off, or you're cheating, and you want to look at that, that would be peeking. You're just looking to see what's at the top element, but you don't take it and put it in your hand, you just look at it. That would be the peek operation. And just like popping, it's constant time. You don't care about what's underneath. All you're doing is taking a look at what's in that top element, and then keeping it right there in the collection. The other operations you would use for stack are just operations that we would discuss using for arrays, which makes sense because they're very similar. They're both linear data structures. So it's going to be helpful sometimes to find out what's the length of a stack. It's also going to be helpful to find out, is the stack empty or not? So those are just sort of general operations that are also useful into stacks. And the implementation is very similar as for arrays. So with that foundation being laid out, we're going to start going to an example problem, just so we can get more of a sense of how these things would be used in a problem, in an interview. So the problem statement we have here is, imagine we have a string, and the string just contains parentheses and brackets. And we want to find out if it's valid. Now, valid here is defined as all the open brackets must be closed by the same type of brackets, and they must be closed in the correct order. So let's see what this looks like. So in the first example, we have an open parentheses and a closed parentheses. True, that meets the criteria. The second one, we have open closed parentheses, open closed brackets, open closed squiggly brackets. True. Now this next one is a little more complicated, but if we remember our two rules, one, anything that's open has to be closed. So for the open normal parentheses, we have a closed one. For the square brackets, we have square brackets, and for the squiggly brackets, we have it closed. And they're closed in order, right? We don't get the matching parentheses for this all the way until all the other ones are gone. So that meets our validity. The next three examples are incorrect examples, they're invalid. So first of all, we start with a closed bracket. So we know this one is wrong. For this one here, we start with an open bracket, that's fine. We have another one, but then we close this one before closing that one. So this one's false, it's invalid. Here, we open with this one, we open, we close, so far so good, we close. But now we have this one, which is unbalanced. It has no matching opening bracket. So this one would be false. So basically, we want our algorithm to be able to say, get in these inputs and return true, and get in these sorts of inputs and return false. So that's our objective for this problem. So the way you would use a stack for this is really clever. So if we went through, that string, so if we went through, let's say this one here, and every time we saw an opening bracket, we pushed it onto the stack. And of course, pushing here just means adding, right? We just added to that group. So if we did that for every time we see an open bracket, then when we see a closed bracket, we should be able to take the last thing we added to the stack and see if it matches, right? Because the last thing we add to the stack is the first thing we'll take out. So let's see. We'll look at something like this and walk through, right? So if I had this sort of scenario, I see an opening bracket, I add it. So now we have one parentheses in our stack. And then I see this and I add it. Now I see a closing one. So if I went back to my stack, the last thing I added to the stack was this, and it matches. So I know that's right. And then you can keep going on that way. But every time you see something that's an opening bracket, you add it to the stack. When you see a closing bracket, you go check the stack and say, does this match? And if it does, you can move on. The first time you get to a point where that doesn't match, then we know we have an issue, because that means now we're having a closing bracket that doesn't have a matching opening bracket that we just added. Any questions there? Because I know this might be a bit difficult to understand in words. Okay, seems like we might be all good. Cool. And so the key thing here is whenever we're doing problems, we always want to think about terminal cases and edge cases. So one big terminal case is, what if we get an empty string? If we get an empty string, you want to ask your interviewer these sorts of questions and say, okay, what would you like me to return if there's an empty string? You know, for this one, we can say, well, if it's empty, then I guess it is valid because they're balanced, right? So for this one, let's just say we can return true. But you always want to ask those sorts of questions. You don't want to just write a solution only for the most common example of a problem that you'll get, because both in interviews and in real life, you're going to hit issues where you get an input that you weren't necessarily expecting, or that isn't, you know, sort of the normal one. And you want to at least anticipate those sorts of things and make sure that that's a part of your discussion with your interviews. That's one thing that interviewers love to see, is that you're thinking about, oh, well, what happens if, you know, this or that. So this is just going through some of the examples. So let's look at the solution in code more and make it a bit more concrete. So we have our method definition here, and this is in Python. And so we can say, first of all, our stack is just empty. And in Python, this just represents, you know, sort of an empty array or, you know, collection. In this case, it's our stack. And so we'll say for each item in the array that we get, the input, for each item, if it's equal to an opening parenthesis or a squiggly brace or a bracket, any of these opening characters, we add it on to the stack. So in this case, in Python, it's using the term append here, but just think of that as push. It's the same thing. So anytime we see one of these, we push it onto the stack, this thing up here. And then here's the edge case I talked about. If we see that the length of the stack is 0, if it's empty, we'll just return false. Now in this case, like I said, you want to ask your interviewer would they want you to return false here or return true. But the key point is that make sure that you cover this case. Then we get to this point. So we'll say if we see, what do we do if we see the closing brackets? So we said first up here, if we see the opening ones, we push them. Here, if we see a closing one, we want to pop from that stack and check with the last thing we added, the last opening brace we had, does it match this closing brace? And if it doesn't, we return false. So here, we've written out the example just for the parentheses, but we repeat this block of code for the squiggly brace and for the bracket. So underneath this, you would have another line, you know, if C equals squiggly brace, if stack.pop doesn't equal the opening squiggly brace, return false. And then below that, you know, if C equals the bracket, if stack.pop is not equal to the opening bracket, return false. So that same check that we did for the parentheses, just do that for each of the types of characters we have. And that'll do it for us. And then at the end, we can just return, this basically is just checking that the thing is empty. So once it's empty, we know that there's nothing more to check, and we can just return true. So that's how this would look in code. And so that's one example of how to use a stack. And in this case, we're checking to see if things are balanced. We add things on when we see them. And then when we get to the second half, we check those things that we've added to see if they match the things we're seeing now. So that's one sort of problem type where stacks come in handy. So I'll break for questions and answers too. I'll bring up the code back again in case anyone wants to ask questions about that. If I have a little time, feel free to ask anything about stacks themselves, about the question we just went over, or about interviewing with stacks. I'll also try to look at anything in the chat if anyone wants to paste a question there instead of saying it out loud. No questions? Okay. Awesome. In that case, here I've pasted some practice problems. So if you want to, get some more experience with these things, definitely go check out these. And of course, there are many more. If you go on any of these websites, Geeks for Geeks, HackerRank, LeetCode, they all have sections specifically for, stacks and queues. So you can definitely go there and practice more. But these are a few that I thought were really helpful. This one here, this last one, the stock span problem, is the one that I was asked in an interview. That's a really good one to know, just because it helps you with a different sort of way of thinking about and using stacks than the problem we just went over. But all these are great examples. Definitely, if you have time, go over them. And if you run into any questions, bring them up with your mentor in your next one-on-one, and they'll help you, get a better feel for it and feel really comfortable with these things. And so with that, I'm going to hand over the controls to Viveka.
Awesome. Thanks so much, Deandra. I also just dropped the problems. We'll be sharing out the slides as usual later, but I just figured if anyone wants to get a head start. All right, let me just present here. Have share and present. Okay. Cool. All right. So thank you so much for that. We will dive into queues now. I'm Viveka, and as Deandra was saying, if you have any questions, feel free to drop them in the chat. We'll try to keep an eye on that, but yeah. Okay, so moving on to queues. I was actually talking to Wentao earlier about these, and he said queues are kind of like Stack's cousin, which I think is very true. And so you see them a lot when the order of tasks is really important. So just kind of like you see a stack in a lot of depth first search implementations for graphs, you'll see the queue is actually used in the breadth first search, and you'll see them in things like load balancers, and they're another data structure to have in your toolbox. It's really it's great to make sure you have a good understanding of them, because in interviews they may come up in useful in implementation, or you might actually be asked about the queue or stack directly in your understanding of that data structure. So to talk about a queue, it is an ordered collection, and it follows the FIFO kind of method, which is first in is first out, as opposed to a stack, which is last in, first out. So examples of this is where, for example, if you're in line at like Starbucks or something, if you're the first in line, you're the person whose order is going to be taking next. Whereas if you're last in line, you have to wait for everyone in front of you to get processed or to get their order taken before it's your turn. And in the same way, if you are using a printer queue, like I had this in school, if I wanted to print something, or at work or somewhere else, if you send a document to be printed to a printer, if you're the first person in the queue, then your document's going to be printed immediately, right? But if there's other people in front of you, then you have to wait for their documents to be printed out before it's your turn. So that's where you see in queues used. That's what we're dealing with here. So whenever anything is added, it will go to the end, and then anything that is taken out should be at the beginning or the first item. So you'll kind of see some parallels in terms of kind of the names and things that you can do with the stack as with the queue. So you add and take away items, and that is what we have here. And it's a little different because we have push, or in a queue is also called, we call it NQ, where you add an item to the rear or the tail of the queue. And that's the same in the stack. You add an item to the end, right, when you add a new item. So for here, you can see we have this NQ. We're adding a 1 into our queue. It's going in. And then we actually NQ another 1. You see that 2 is also going to the end of the queue. And you can also call that push. But for a queue specifically, we would call it NQ. And then you have the DQ, where you're removing an item just like pop removes an item from the stack. Though here, if this were a stack, we would pop the 2 because we added that most recently. However, this is a queue, so we're actually adding the number or I'm sorry, we're removing 1 because we added that first. We're moving it from the front of the queue. So just like if you imagine this is like a coffee shop, the first person comes and is standing in line and waiting. The second person comes and is standing in line and waiting. The first person is going to get their order taken. Now they're done. They get DQ'd. And then talk about the other operations. These, again, are, they have exactly the same names for stacks. And they are similar. You have peak, which is the same as a stack in that you are basically returning the element that you would pop without taking it out of the data structure in the queue. But again, it's the first element instead of the last one. So that's like saying, who's first in line? You're not taking them out of line, but you're just asking who is first. Oh, it's this one, or it's 1, or whatever. And then both size and empty and is empty, exactly the same as a stack. They just tell you how many items or if there's any items at all in your data structure. So that was kind of the basics of the, the functions. Let me just check the chat, see how we're doing. If any questions come up, feel free. So now we're going to move along to think about implementation of a queue. And there's a number of ways to do this. You can see we have here kind of the common implementations are a linked list where you have the front and the rear. And so, of course, you have a linked list, so you have nodes and you're linking to the next item and you want to make sure you know where your front is. And now in some implementations, you may have a rear pointer as well, which can be helpful if you think, because you want to add items to the rear. Though this may or may not be the case depending on the linked list you're using. And then, of course, we have the array-based implementation where you add numbers, you have some front. So we'll say, let's say the front is at the 0th index with the 12. You're adding items as you go down. So if we think about the array-based implementation, dive into a little more. Now, again, we're defining our class queue. We have the functions that we want. And so we have isEmpty, enqueue, dequeue, size. Oops, sorry about that. We don't see a peak, but we can talk about that really quick because it's going to be very similar to the dequeue. Because you're looking at the same element. You're just removing it or looking at it. So in the array-based implementation, we're of course going to start with an empty array. I clicked. So we have our items. This is our collection. We're starting with an empty array because we're using our array to implement our queue here. And so then isEmpty is going to be very simple. You're just saying, is my items empty? So that's pretty straightforward. And then as well, the size. You're just looking at how many items you have, how many elements are in your self.items. There's your size. Pretty straightforward. Now, the enqueue is going to insert items here. And this looks like Python here. So we're inserting, it says 0 at item. So it looks like in this case, we're adding items to the beginning of the array here in Python, which is fine, but that means that our head or the front of our queue is actually at the end of the array. So we can see that up here, which means when we want to remove items, we want to remove them from the end because that's where the front of the queue is. And you can see here, we now have self.items.pop. And in Python, this will take it off the end, which is what we want to do for this queue using an array. Now, that was kind of a lot of things, so I'm going to pause there just in case anyone wants me to clarify. Happy to do that. But if not, I'm going to keep moving on. And of course, anytime you have questions, feel free to pop in the chat. Oh, did I hear something?
Yeah, sorry, I just had a quick question. So one thing I'm noticing is like for the queue, like you're kind of showing the actual implementation versus the stack. It seemed like we were just using a library that already kind of has the implementation of the stack built in. Is that the case?
Yeah, so you'll see the way we're actually using this is kind of, we're using a Python array here. It can be language specific, but you'll see this pop is a built-in item for an array in Python, which kind of acts like a pop in a stack, right? Because you're moving it off the end. So in some ways it'll depend on the language. And I know kind of a common piece of advice is, if you're going to be interviewing, just like focus on interviewing in one language, and you sometimes can use that to your advantage here because you'll see this is this is also kind of like a pseudo stack a little bit. Does that make sense?
Just to jump in here, yeah, that's a really good point. So for stacks, I could have done something similar to this. The thing is with Python is actually, Python does a lot of this work for you, which is nice when you're actually programming. But for interviews, as Rebecca said, like it is good to have these sorts of things. So you could do a similar thing for stack. You could implement it sort of yourself in Python. And this is just showing what that would look like for queues. So if anyone wants to see the implementation for stack, just post that in the chat and I can write that up for everybody. But this is really helpful that she has this. So thank you.
Cool. And I'm sorry, just to ask a follow-up question. So and then I guess with Python, is there like already a library that has Q that kind of does all this work already as well? Because I'm not familiar with Python. This is why I'm asking.
It's not really a library so much as it's just the language itself. Like you don't have to import anything, but like arrays have like an append method, for example, and the append method is going to do basically the same thing as insert or insert as she's using here. So you don't really have to import anything per se. So it's not really a library. It's just it's like a built-in part of the language.
Yeah, append actually. We'll add it to the end versus insert. We're being very explicit here. About adding it to the front, because in this particular implementation, we're saying like the 0th index, the lower the index, like the farther along you are in the queue. Does that make sense?
Yeah, that makes sense. Thanks a lot.
Yeah, for sure. And it is helpful to know it sometimes. Yeah, I think as DeAndre mentioned, there's a little bit of a difference between like when you're actually programming versus interviewing. You want to make sure you're explicit, because especially Python. I have friends who interview in Python. There's a lot of use in sets that can make your solutions, you can make it very easy to come to the solutions to common coding problems, but sometimes the interviewer will say, okay, can you like break that down a little bit so we can show you understand kind of the theory behind it. So it's, as we've been talking about, interviewing is a little bit of a different skill. So that's why it's really good to have these basics. And so please, all of the questions, we're happy to answer them. Great.
So I guess, sorry, can I just ask one more?
Yes, go ahead.
Oh, yeah, sure. So I guess for the insert, one thing I was confused with for the NQ, the insert, it says that it's inserting it into the 0 position. Does that mean that it's automatically moving everything to the right in this array?
For this Python insert, yes, that's what's happening.
Cool. Thank you.
Yeah. So this particular implementation. If you wanted, you could say the front is at 0 and then use another enqueuing function that will add it to the end. So this is just one. This is not, I want to be clear, this is not like the implementation to make it for a queue using an array. Like this is just an example of one. So this is a choice here to say we insert at the 0th index and we pop from like the later indices. Cool. All right, I'm gonna move on, but if anyone has any questions, yeah, feel free to call them out or put them in the chat. So then we can talk about the time complexity here, which is an important thing to think about. So for a linked list-based implementation, which we didn't show out all the way, but we showed kind of in the diagram, if you're gonna push or on queue, which means you're adding an element to your queue, that could be 0 of n or 0 of 1. And again, this is gonna depend on your implementation. So if we go back, we see this linked list, we have pointers to the front and the rear. And remember, you want to add your elements for a queue at the rear. So if you know where the rear is, you can just add a new element right here, and that's going to be constant time because you're just adding a single element and then you're updating rear. That's going to be the same no matter how big your queue is. But a lot of lists don't have the rear pointer. So if you didn't have that rear pointer, you would have to start at the front, go to the end until there are no more items, and then add it. So that's why it can be O of n time if you don't have that pointer. Oops. But if you do have the rear pointer, then it'll be constant time. And then for pop, usually we always have that front pointer, and you're just updating, you're just removing the item at the front and then setting your head to the next one. So that is always going to be constant time as long as you have that front pointer, which is usually very common. Now, for the array-based implementation, remember, we talked about putting the queue, where do you want to define the queue's front or head? Do you want to put it at the beginning of the array or the end? And in this example that I just showed you, that code example, we had it at the end, remember, because we were adding stuff to the 0th index, but the front or the head was at the higher indices. So as, I'm sorry, oh my God, I lost your name, but easy. Is that's what I see.
Yeah, Ed, no worries.
Yeah. With that insert, you exactly pointed out when you were pushing, when we put that insert at 0, we're moving everything down. So that's why we have that 0 end time, just like you pointed out there. And then the pop, we're just popping it out off the end. That's going to be a constant time because it's just at the end, we just knock it off. We don't have to change anything else. Now, if you put the front or head at the beginning of the array, that of course you're going to reverse it, right? So pop, you have to go all the way down to remove that item. Or sorry, you would remove it at the front, but then you have to move everything up because you don't want to have an empty 0th index, right? And then push is going to be, you just add it to the end. Now there's a little note here, if because in some language, in Python, this is not the case, but in other languages, when you define an array, it's going to have like a hard length. So if you add stuff that's longer than your array, you might have to resize it. You might have to copy everything over to a new array. So in the worst case, yeah, you have to copy everything over. That's where that 0 end comes from. But on average, usually you just add it into the new element in your array. So that's why we have constant time for average time complexity to NQ here. Now that was a lot of information, so I'm going to pause again just in case anyone has questions about that. Okay, gonna go to the next slide then. So now we have a sample problem. And again, this is why we're trying to show you these are very, you can see these are very related. There's some overlap here. So this problem statement is implement a queue using 2 stacks. So how we want to think about how we would do that. And again, what is a queue? So what do we need for a queue? Well, we need those functions we were talking about. We need to be able to push. We need to be able to add an item. And again, that item is going to go to the back of our queue, however we choose to define that. We want to pop an item, which means remove it. And again, that's going to be from the front because it's a queue. And then peek, which is going to be getting the front element. And then empty is just going to be a Boolean. And you can see here in this particular problem statement, pop and peek are going to return ints. So we can assume that we're working with like a stack that a queue that's going to be taking integers. Now, again, as a reminder, stack is LIFO, last in, first out. Queues are FIFO, first in, first out. So how can we show, how can we basically make kind of, what's the word? Kind of convey the functions of a queue using a stack. Well, if you think about it, if you put items 1, 2, 3 in a queue in a stack, the stack is going to be the reverse order of what you want in the queue because 3 is going to be at the top. If you do 1, 2, 3 in a stack versus a queue 1, 2, 3, 1 is going to be at the top. So if we have 2 stacks, you take all the items from one stack and you dump them in the other stack. Now your order is reversed, and now you have, when you go to pop through them, you have the order that you would have if you had one queue. That's the general idea behind this. We're going to get into the actual implementation in just a minute, but I just want to take a second to pause there to make sure people kind of see where we're going with this. Okay, now bear with me. There's a lot of information on this slide, but it is useful to kind of see kind of that visually, how we're going to start to get into that. How do we reverse things a little more? So we have 2 stacks. Let's say we add 1 item. So that's going to be in stack A. Now, you can think of this stack as kind of where we're continuing to store everything. That's where we're going to use it. So value A is already here, and now B is getting pushed onto this stack or on queued onto our queue, because remember, both of these stacks are representing the queue that we're implementing. Now, we want, let's say, remember, we want ideally to have, you can decide if you want push or pop to be optimized. Remember, because we talked about up here in the complexity, if you have an array-based implementation, you're looking at one of these is going to be constant, one of them is going to be linear? And that's a great question to ask the interviewer. What do we care about more? Because they didn't say that in the problem statement. They just say remove or add. So that's a great question. Be like, okay, well, let me think about this. Do you want pop to be the fast one, or do you want push? Now, here we have peak. Oops. So that kind of implies we want to be able to get the front element really quickly. So, well, that's a great question to ask, but for this implementation, we're going to assume that we want to be able to get the front element fast, because otherwise pop and peak are going to be slow and push is going to be fast. But again, that's a question to ask and a choice that you can think about making when you implement stuff like this. So in that case, we want to get the first element quickly. So that means we want to basically have a stack that has those elements in order. So that way when we pop, we have the first element, kind of the front of the stack. So let's say we want to make sure that's always true in stack 1. So now we only have one element A, that's going to be in order no matter what, because it's one element. Now we want to add B. Now let's think about it. If we want B to be added to our queue, we want to add it at the end. And if stack 1 is always in order, we can't add it yet here, because then we'll have BA. And when you try and pop off the stack to get the item at the front of the queue, you're going to return B, which is not correct. So what we do is we pop A or anything else that's in here. We're going to move that to stack 2. And that's going to be like our holding place. This is kind of like our workspace, So now we can put B here, because B is going to go at the bottom of the stack. It's going to be at the end. And now that's totally fine. And now, again, we can put everything back in. We can take A from stack 2 and put it into B. And that, once we do that, we now have A, B, and that is the order we wanted. Remember, because we had A first and then B. So whenever we say, if we were to say at this point, now we want a peak, we could just say, okay, use the stack 1's peak method, which will return A, which is correct. So we're using the stack 2 to kind of push everything over and then pop it off again and push it back so that we maintain the order that we're looking for. How does everyone feel about that? Okay. We're going to get into the code a little bit. Again, we're using Python. So, if stuff looks a little different, don't worry about it. This can be a great exercise to try, in whatever language you're focusing on interviews in. But we're going to start off with our initialization, which is, we're going to start with 2 stacks, which makes sense because that was part of the problem statement. So we have stack 1 and stack 2. And remember, stack 1 is going to maintain the order that we actually want for the queue. And stack 2 is kind of like our secondary workspace stack.
Rebecca, could I ask a quick question?
Sure. Yes, go ahead.
Yeah, sorry. So I know we were saying that the time complexity, it seems like linked lists will be a way, would just be a better way to go, right? Because it'd be constant if you have that rear pointer. So I guess with that, if you wanted to use linked lists in Python, is there a quick node implementation that you could just call, or would you then have to recreate that? I'm just curious about that.
I think you would, I believe you would make your own node. I'd have to check that because I don't interview in Python usually. We were trying to kind of keep it standard. But I think it'd be pretty simple to, at the very least, you could just define an object that has a node, the value, and then the pointer to the next node, I think.
That's exactly what you do.
But I think, yeah.
Yep, and just to chime in, I think in my few years of working with Python, I'm not aware of any kind of a standard library for linked lists in Python. But if you were to roll custom implementation or data structure that represents linked lists in Python, you can certainly do that. And in fact, that will be something that we'll be covering in the next lesson, which will be kind of diving deeper into linked lists.
Awesome. To be continued then. But good question. It's always good to think about these things. Because, whenever you get a problem, there's a lot of possibilities. Okay. So again, go over initialization. We start with 2 stacks because that's what the problem told us to do. So now we're going to talk about push. Now remember, we have stacks. So we're assuming these stacks are already, implemented here. So we have these. So remember, when we push, as we talked about, we want to move all the items from stack 1 onto stack 2. So we have while stack 1 is not empty, take everything. We're going to add everything onto stack 2, which is a pen, but really we're pushing onto stack 2 everything that's on stack 1. We're going to pop everything onto stack 1 and push it. Is it empty? No, it's not. We're going to keep taking everything from stack 1, put it on stack 2 until it's empty. And once we've done that, stack 1's empty. Now we can add our new item X onto stack 1. And again, this append, we're really pushing X onto stack 1. And now we do the reverse. While stack 2 is not empty, take everything from stack 2, pop it, put it on stack 1. So this is exactly what we were talking about in the diagram here. Basic idea, make sure take everything from stack 1, put it in stack 2, put your new item in stack 1, and then put everything else back onto stack 1 out of stack 2. So when we're done with this, of course, stack 2 should be empty again. Now for pop, again, remember I was talking about you make those decisions, what's going to be faster or slower. Here we're optimizing where pop is faster. And so that's very simple. As long as there's something in stack 1, pop it off. There you go. And then of course peak, actually if you look at the slides, only these things have changed. Again, as long as stack 1 is not empty, you return the index -1. Now that this is a Python thing, this will return the last item in your stack, which is essentially the same thing. And again, there's other ways to implement it. This is Python specific, but all you want to do is take the last item in your stack and say, here it is. And remember, see, we're not changing the stack at all. We're just giving back the item that has to be at the last index in the stack here. And now empty, of course, is also going to be pretty simple because, like I said, stack 2 should always be empty except when you're working with it. And we only work with stack 2 in push because we have to put everything from stack 1 onto stack 2. So for empty, we only have to check stack 1 because stack 1 is maintaining our queue order. So that's pretty straightforward there. Okay, so before we get into the time complexity, does anyone have any questions about the implementation? Okay. So as we talked about, here we have push. Push, we have to move all the elements over and then move all the elements back. So that's going to be linear time because every element other than the last one is pushed and popped twice. Now that becomes linear because we technically have 4 times n. But remember, in big O notation, we don't care about that constant, what's the word, coefficient. Whew. Algebra throwback. But that number in front of the n we don't care about. So that becomes just linear time because for every element, that is a constant of 4 times that we're moving it back and forth. Now pop, as we saw, both pop and dequeue, we already have it all set up. So we have this stack that's just going to pop it off or dequeue it. So that's constant time because we know exactly what element we want. And we say, here, you can have this element. And then peak is exactly the same. We have it set up that we're just accessing the last element in the stack, know exactly where it is. Here you go, we return that. And then again, for empty, you only have to check, you're using actually the stack empty here, which also it's constant time because you're just checking if the size is 0. So that again is going to be constant. Oop, I think I may have, here we go. So does anyone have any questions on the time complexity or the implementation of the queue using stacks problem? Okay. So if you want to practice, here are some LeetCode problems. We have implement queue. There's also implement stacks using queues. You can search for that in LeetCode. I didn't add that here, but these are all the LeetCode problem numbers. So here are a bunch of problems, and also like Deandra said, Geeks for Geeks is also if you search that, is also going to have some great stuff. And now some of these, I think it's a great time to point out, these are all tools for you in your toolbox when you're interviewing. You don't necessarily need to use a queue in a problem. And sometimes you might think I could use a queue, but I think this would be better, like a hash map or a stack or something else might be better. So that's a really great thing to think about and practice. You can try things with a queue, you can try it with something else. You don't always have to use particular data structure, but it's good to know your options and be able to kind of do a little analysis of the trade-offs. Cool. And with that, I think that pretty much concludes the queues as well. So we're gonna leave some time for Q&A for queues, stacks, or any other questions you have. And if, Deandra, if you want to add anything as well.
No, that was awesome. Thank you.
Great, thank you.
Right, thanks guys. Yeah, that was a really, really helpful instruction on these two topics. But yeah, right now we want to kind of open up to the floor and ask if there's any questions about the topics or any kind of things that got covered today. Yeah, feel free to kind of like, put in a chat or just like also just voice it out in this call as well. Let's see, no questions? Huh. Eduardo says, so what you're saying is learn Python for interviews. Well, I believe, different people have different takes on it, and it also certainly depends on the job. But for any kind of generic interview that are like oftentimes at like any kind of like web-based or product-based companies, Pythons could be helpful because it just requires to write less code and doesn't require to like manage your own data structures. A lot of times they're just kind of like giving us like a built-in data structure to you. However, there are definitely roles where the companies do require you to know like a certain language, or they may want to make you code in like a memory managed language. In like a more like a compiled language such as C++, just to like really gauge like how much you know about low-level programming language. So for those things, yeah, like knowing C++ or C could also be helpful. All right, so we got a couple more questions. Let's see, Deandra or Viveka, do you want to take them on?
Sure. You look in the chat. Would there? Yeah, looking for the. I actually just as a side note, I interview in JavaScript because I do a lot of front end work, and I'm just most comfortable with JavaScript. And incidentally, their array also has like a pop method, so it's kind of funny. But yeah, I don't think you'll get dinged for using a particular language, but as Wenta points out, Python has kind of the benefit of being really fast to type up versus like Java or C++, where you have to kind of, if you're actually trying to run something, you have to do like a public static main or whatever. But really, as long as you know the language, because again, you might be able, languages with the shortcuts are great, but I have seen interviewers like kind of call you out and be like, okay, you have to actually explain this, or actually, can you implement it without the shortcut? So, just something to be mindful of, but whatever you're comfortable in is the best language. And then would there be a situation where you would use array over nodes for implementation? Yeah, I think there would. And I think I have seen questions where it's like implement a queue using nodes. Or I think a queue would make sense. Or you'll see like a double-ended queue, which is sometimes called a deck, which is a little confusing, DEQUE. Where you can add items to the front or the back. And that you could use an array or a linked list for as well, or maybe a doubly linked list. So I wouldn't say it's because of language limitations. I'd say in this case, it was the problem statement explicitly was implement a queue using two stacks. But if you don't have that requirement, then it's kind of up to you to ask questions of the interviewer and figure out what they're trying to optimize for, what matters to them in the question. Did anyone want to add anything to that, Deandra?
think that's a good explanation. As far as the first question about languages, so in my perspective, I do interview in Python, and actually in my current job, I use Python more than anything. And yes, it is it is helpful in the sense that a lot of the stuff is sort of kind of built in, and it's more readable. It looks more like human language, more like English than maybe like C++ or something like that. But at the same time, I would say don't let that be like a crutch for you, because it's easy if you just start off with Python. It's easy to not necessarily really learn how things are working underneath. And so I would say just make sure that you're focusing also on like knowing how these things work, right? It's really easy to just sort of use the pop method and not really necessarily know what it's doing. So just make sure that you really understand whatever language you're using. Make sure you're understanding like what are these data structures actually? What would they look like? Because you definitely may get in a situation where you say, oh, okay, well, I'll just use this. And an interviewer says, oh, well, actually, how would you implement this? Or, whatever. And if you feel like, oh, I want to just use pop or whatever, or I want to use this built-in thing, make sure that you do know how you would actually implement it. So just always kind of keep that in mind. And for the question on stacks versus queues, so the main way to identify it would be something along the lines of how you're removing elements or how you're adding elements. Order is really the key there. That's the key thing that differentiates them. It's like, do I want access to the last thing easily, or do I want access to the first thing easily? With a queue, like, do I want to have to go all the way down to the end to get that one, or do I want to be able to just take something from the end, or vice versa? Do I want to be able to just, if I'm using a stack, if I want to get the first thing that was added, I have to go way, way, way down. With a queue, it's the first element. So ordering is really going to be the answer to that question. And I think there was a good point made about these are tools. So oftentimes, at least for me, when I'm in an interview or I'm thinking about just a problem in general, even just at work, I like to think of like a solution first, and just think, okay, just generally, not even thinking about a data structure per se, but like, how would I go about solving this problem? What would be a good way? And once I have that general idea, from there, I try to find, okay, what would be the best, tool to use or something like that. So as opposed to like picking the tool first and then trying to like fit it to the problem. As you go on, you'll see which way works best for you. But for me, I generally try to think of an idea of how something would work. And then from there, it's a lot clearer to me, oh, well, yeah, I should use a stack or a queue or a linked list or, whatever. So for the last question that was just asked, for sure, if you look at some of the practice problems that we added on both of our slides, and they're also pasted in the chat, those are some questions. They're not going to explicitly say, use a stack or the queue. The one with, make a stack using two queues, obviously that one's really explicit, but oftentimes you will get ones that are a bit more subtle. Like the first one I did with the parentheses, that one, the problem statement didn't say use a stack to do this. But obviously the problem was easier to solve when you use one. So, but there are more examples like that pasted in the practice problems. And, if you run into any confusion with those or whatever, just reach out to your mentors.
Yep, and then to kind of like add more examples, we're going to cover these topics in the future, but in breadth first search and depth first search, you will also see kind of like queues and stacks also just show up, perhaps like sometimes implicitly. For example, breadth first search, when you're kind of like setting up the order of the traversal or order of visiting different nodes, oftentimes you're like using like a queue because you want to keep that like first in first out order, like, or the FIFO order, right? So that you can actually kind of visit them like level by level, and then visit them in the order that that you came across in. Whereas like for DFS or depth first search, in which you're kind of like going as deep as you can in visiting the the node in your graph, oftentimes you're using recursion, but recursion is oftentimes like more like implicit implementation where there's also a stack, right? So there you could also like actually implement like a DFS using stack, because like what you do is basically so you kind of come across like different nodes in like another level. You want to keep them, but you also don't want to like visit some of them or most of them until like later, because you want to just keep going down like this one path. So in that case, like using like Q to kind of keep that order of like LIFO or like sorry, I'm kind of messing up here too, but last in first out or LIFO is really helpful. So yeah, you also like show up in those two settings as well. And then we had one more question. Yeah, how do you identify when it's best to use a stack versus queue? Once again, I think it's important to kind of like highlight or just like remember the difference in their orders, right? So stack is where we have the last in first out or LIFO, and queue is where we have like first in first out, right? So there'll be times where you naturally think, okay, well, I want to like visit certain items in like certain orders, and which is it? As long as you kind of like remember which data structure has which order, then that will be helpful. But yeah, I think that that's something that I would like to just highlight for that question. All right. Sounds like we covered a lot of questions. But yeah, feel free to ping us in the Slack channel, or also feel free to ask your mentors about any of these. But yeah, thank you guys so much for all these questions. Let's see. I know we are over the 1 hour mark, but technically we have the 90-minute schedule for today's lesson. So if anyone's interested, we can stick around for like a Q&A. About just like how the mentors have gotten into computer science field themselves. Sorry, we were kind of like rushed in the beginning of the lesson and didn't really go over the intro, in too much in depth. But in case you guys haven't noticed, the two mentors today who gave the lesson are really accomplished engineers. So Deandra is a software engineer at Microsoft, and Viveka is a software engineer at Square, and they're also the first pair of female software engineers that we have in this cohort to give lessons. So if anyone's interested in asking them about like how they got into software engineering career, or any kind of like tips that you may want to ask them, feel free. And we just spend this remaining of time covering that. Yeah, any questions?
I have one question. I guess for both of y'all. What do you feel is like the main thing you did that helped position you to actually get the job you currently have? Is it was it like really grinding like leak code questions, or was it like projects, or I don't know.
So for me, I had sort of an interesting sort of background. I started off doing biomedical engineering actually in college. And so a lot of my sort of exposure to computer science was, we did some in class, we did some programming, but a lot of it was in research. So my practical sort of work programming wasn't really in sort of the typical data structures and algorithms efficient coding way. It was just like, I have a research problem and I need to code up a solution. So I think for me, when I went to sort of transition into actually writing software, I needed the practice of basically what you guys are doing now. I needed a lot of going through problems, looking at approaching problems in a very sort of more structured, more efficient way. And so hacking, the coding interview, all those sorts of like books and these different questions, I spend a ton of time on those things. But if your experience is a little different and maybe you come from a more like standard CS background and you've been doing internships or you've been doing software engineering, you might find that those projects lend themselves better to the interview and lend themselves better to the future job you end up doing. So I think it just depends on like where you are, like what your strengths are and the way you approach problems right now. And so there may be one method of closing that gap that's a little better than the others. For me, it happened to be this sort of just concrete preparing for the interview itself. But for other people, the work that they do in a summer internship or during the year may actually mimic the work they'd be doing a little closer.
Yeah, I will say, I think interviewing for me definitely feels like a muscle that I need to continue to work at. And it feels, I think it's true, even if you are, programming for a while, it's a very different approach when you are in a job and you say, here's a problem you want to solve. Usually you have, time to think, you get some familiarity with the business, you're kind of coming at it from a different angle. So I do think versus the kind of classic 45 minutes to an hour technical interview, it is, I think, a skill that needs to, unfortunately, there are discussions out there about, how representative of this is, close enough to your experience as a software engineer, even if you already are working as that. And, that's a whole nother discussion that for now is not as relevant, because the fact of the matter is, for most software engineering roles, you're going to be expected to do this kind of interview. So it is a muscle. And I just started a new role in January, and I was interviewing, and that is something I had to come back to and be like, oh, do I know how a stack and a queue works? Yes. But the ability to say, to be in front of someone, they say, here's a problem statement. Now, well, walk me through and get yourself to a solution in, 45 minutes. That's a very particular skill. And I do think, it takes time. And like Deandra said, there are some great resources out there. And a lot of that is the practice, and everyone struggles with different things. Some people struggle on a particular data element. So in my case, sometimes if I don't know the answer right away, which is very, very common, you're not expected to have the answer known or memorized, I do get an initial panic, oh my God, now I have to solve this problem, which is part of it. But a lot of that is the practice that comes with getting used to it. And like someone was asking, how do you identify when it's best to use a stack versus a queue? And Deandra very correctly pointed out, you have to think about what you're prioritizing. You're prioritizing the order of the front or the order of the back. And then on top of that, even, is frankly practice. You just get comfortable enough. And honestly, even if you implemented something with a queue and then you went through and you're like, actually, I think a stack will be better. That does show the interview. You're thinking critically. You're not just saying, this is it, it's done, nobody question it. Being able to question is a really important skill. So all this to say, a lot of it is just kind of practice and then getting comfortable with it.
I 100% agree with everything there. It definitely is not, it's not, the experience of an interview is just different than what you do. If you took my lead engineer at my job and just pulled him off of his computer and said, okay, let's do a coding interview, he probably would nail it. And he's an excellent engineer. It's just a bit different. I'm a really big football fan. And what comes to mind for me is, the way I think about it is, you have the best players and they go into the draft. They've been playing football this entire season, but they prepare specifically for the combine, where they go and they see who can jump the highest and who can catch this or whatever. Those are not exactly the same things that they'd be doing in the game, but it's a good proxy for teams to see how well they'd be able to do things in the game. So they'll train specifically for the broad jump or for the whatever, even though they're not going to do those specific things in the game in the fall, but it helps them prepare. And it's a similar sort of thing. And I think a lot of people will sort of critique the interview process and say it's not what you'll be doing as a job, which is true. But one thing I do think is important to keep in mind is there are some threads that are really similar and really helpful. So one is going to be the idea of just thinking about a problem and coming up with a way to solve it, even if it's not the best one. Like the last thing Viveka mentioned about, okay, I've solved this one way and thinking, oh wait, actually there may be another way to solve it. That's something you use every single day. And I went over this with my mentee in our last session. You know, if you have a problem, someone gives you a problem in the interview and you think, okay, I know an easy way to solve this. There's probably a better way. You want to mention that to the interviewer and say, okay, this would be a way to solve this just so we can get it done. Would you like me to show you that? Or would you like me to go into like, try to think of something better and optimize? And that's the way we do things in real work too. You want to have, because at the end of the day, as a software engineer, your job is to like build things. And you know, it doesn't have to be, the first example doesn't have to be the best code anyone's ever written. You want to have something that works, and then you can iterate on it later. So that method, that way of thinking is very applicable to the job. And thinking about edge cases, you know, the sort of thing of, okay, what are possible ways this could go wrong before I start writing out something? That's also something that a muscle that you'll work a lot as an actual engineer. And the final thing I'd say too is it can be awkward to, you know, be there standing in a room with somebody and explaining to them your entire thought process as you go along. And that itself, you won't necessarily replicate in a job, but you will have to explain your code, and you will have, you know, code reviews, and people will go in and ask, okay, well, why did you do that? Or could you do this differently or whatever? And so getting to the place where you can explain your thought process and explain why you did things and be open to evaluating different ways of doing it with other people and communicating, that's also a great skill. So while the experience is not exactly the same as what you'll be doing, there are a lot of things that you'll be able to pull from once you get the job. So it's not like you're just training for something and then it has no relevance whatsoever. There is some relevance to it.
Yeah, I totally agree with all of that. Also, I don't even follow sports or anything, but I love that football analogy. That was great.
Oh, thank you. Great. Okay, great.
All right. Yeah, that was super insightful analogy. Really enjoyed that myself. Let's see. Do we have any other questions today? Let's see. If not, are there like any kind of parting messages that you guys want to share, Deandra and Viveka?
Just best of luck, everybody. I think really good questions on everything. You guys are thinking about it in the right way, and yeah, just keep working. Also, feel free. I think you guys all have my LinkedIn. You can just look up my name. I'm the only Deandra Peck. And so, you know, feel free to reach out there on Slack.
Yeah, same here. And I just want to say, like I said, I interviewed very recently. I do have some years of experience. I continue to bomb interviews on occasion, you know, like it still happens.
Yeah.
You have to pick yourself up and be like, you know, sometimes it wasn't meant to be. But, you know, don't let a single, you know, experience like that kind of shake like all the work you have done, because it happens. Life happens.
Definitely.
Got it. Well, thank you so much for volunteering with Techquitable on a Sunday morning / afternoon. Yeah, really appreciate the wisdom and expertise you bring to this topic. So thank you guys. And for the fellows, you can kind of catch up, review all this thing that we went over today on recorded video, as well as the lesson slide that will be posted on Slack channel later today. So thank you guys. And I hope you have a wonderful week ahead.
Thank you, everyone.
Thank you.
Thank you.